Hello dear friends, myself Sunil Sonigra, and today in the subject of mechanical drafting we will discuss the chapter titled as Projections and Sections of Solids. In this chapter today we will discuss various aspects, basic concepts related to projections and sections of solids. And the objectives of today's discussion covers: the first is to understand the concept of the basic terms of projections of solid, to study various types of solids, and to identify the position of solids in given position. How to draw the solid in given position, that we will discuss in today's presentation. In projections of solids, what do you mean by solid? What is solid? So solid is a 3D object having length, breadth and thickness and bounded by surfaces which may be either plane or curved, or it may be combination of plane and curve both. That is called as solid. So it's a covered boundary with the surfaces. The surfaces may be regular or it may be irregular surfaces, and based on those surfaces the solids may be subclassified. These are the solids. You can say it's first is the rectangular prism, then second this is sphere, this is cone, cylinder, pyramid, and this is cube. Now in solid, the classification of solids is based on two categories. The first is polyhedron, second is regular polyhedron. In polyhedron, the subclassification is regular polyhedron and other polyhedra, and second type of solid, that is solids of revolution. Now in solid, the first, that is polyhedron. What do you mean by polyhedron and how to classify various polyhedrons? The first is regular polyhedron. The solid bounded only by plane surfaces or faces, that comes under this category. Its faces are formed by regular polygons of same size and all dihedral angles are equal to one another. For example, cube. Cube is having all faces are of equal shape and size. So those type of solids comes under the category of regular polyhedron. Other polyhedra, when the faces of a polyhedron are not formed by equal and identical faces, they may be classified into prisms and pyramid. So these are the solids which comes under the category of polyhedron. In polyhedron, there are 7 regular polyhedrons. The first is prism, second is pyramid, tetrahedron, cube or hexahedron, octahedron, dodecahedron, and icosahedron. These are the solids which comes under the category of regular polyhedron. The first is prism. What is definition of prism? So it is a polyhedra having two equal and similar faces, called its ends or bases parallel to each other and joined by other faces which are rectangles. So that is called as prism. This is one typical triangular prism. Two triangular faces are joined, upper face, this is upper face, lower face with these slant edges, and 3 rectangular faces are there on all 3 sides. This is called as the axis, which joins the midpoint of upper triangle and CG or midpoint of lower triangle. This is called as the faces, the upper face and lower face, both are triangular in shape. Edges, these are the edges 1, 2 and 3 edges are there. The imaginary line joining the centers of the bases or faces is called axis of prism. This is the axis. It joins the faces, the center of both the faces. In prism, according to the shape of its base, prism can be subclassified into following types. That is triangular prism. This is the triangular prism as we had seen. And second is square prism. This is the square prism. The upper face and lower face both are square shaped and these corners are joined with the straight edges, and 4 rectangular shapes are there. So 4 equal rectangles and 2 equal squares. Number C, that is pentagonal prism. This is the pentagonal prism. Upper pentagonal face and lower pentagonal face are joined with the straight lines. And hexagonal prism means 2 hexagons are joined with the straight lines as shown over here. This is the axis of hexagonal prism and this is axis of pentagonal prism. Now pyramid. Second is pyramid in polyhedron. This is a polyhedra having plane surface as a base and a number of triangular faces meeting at a point called the vertex or apex point. That is called as pyramid. So it is the polyhedra having one triangular face or one regular polygon, and each end of this regular polygon is joined to a point which is called as vertex or apex point, and hence here triangles will be formed. In case of triangular pyramid, 3 triangles would be formed. In case of square pyramid or pentagonal pyramid, appropriate number of triangles would be formed. In square pyramid, 4 triangles would be there. In pentagonal pyramid, 5 triangles would be there. In hexagonal pyramid, 6 triangles would be there. This is called as the axis of pyramid. Edges, these are the edges, slant edges, and this is the base of pyramid. It's a triangular in this particular figure. The imaginary line joining the apex with the center of the base is called axis of pyramid. This is the axis of pyramid. It joins the apex point of this pyramid to the midpoint of this base. Now, according to the shape of its base, the pyramid can be subclassified into following types. These are the types of pyramids. The triangular pyramid, this is the triangular pyramid A, and this is the square pyramid having square base. So this square base is joined with this apex point as shown over here. Here triangular shape is joined to the apex point, that is triangular pyramid. According to the shape of its base, the pyramid can be subclassified as we have seen. Pentagonal pyramid means pentagonal base is there and that is joined with the apex point, and hexagonal pyramid, a hexagonal base is there which is joined to an apex point or vertex point. Now polyhedron. What is polyhedron? A tetrahedron, 3 equal equilateral triangular faces, that is called as polyhedron. This is a polyhedron, it's a typical shape solid. And second is cube, 6 equal square faces, and this is a cube. So both this comes under the category of polyhedron. So if in example sometimes the data is given like tetrahedron is given, so nothing else would be given, only the side length, that is 30 mm or x mm side length is given, and it is given that the tetrahedron is resting on its HP. So in those cases the tetrahedron means 4 equal triangles, equilateral triangles, 3 equilateral triangles, and it forms a pyramid, triangular pyramid. In polyhedron, one more, that is octahedron. So this is an octahedron, 8 equal equilateral triangles are there, so that forms octahedron. And dodecahedron means 12 equal regular pentagonal faces are there. Of course it is not in our syllabus, but just for the information we can use over here dodecahedron, and this shape is useful in field of nanotechnology, that is dodecahedron. Solids. Number 2, other polyhedra. When faces of a polyhedron are not formed by equal and identical faces, they may be classified into prisms and pyramid. That is other polyhedras. These are the various solids. Say this is square prism, pentagonal prism, hexagonal prism, rectangular prism, and oblique prism, in which the axis is inclined to this base. It's not at a right angle to the base, so those solids comes called as oblique prisms or oblique solids. These are the solids: sphere, cube, cuboid, cone, cylinder, and square based pyramid, triangular based pyramid, triangular prism, and hexagonal prism. So these are various solids which we will study in today's discussion. Now first example. The data of first example is given like this. A right regular pentagonal prism, side of base 30 mm and height of axis is 75 mm, rests on HP on one of its base corners such that its long edge containing the corner is inclined to the HP at 60-degree angle. Draw its projection. So here a regular pentagonal pyramid is given, and further it is given that axis parallel to VP and inclined to HP by theta angle is given, and also inclined to profile plane. So the data in short we can write like this: pentagonal prism, 30 mm side length, 75 mm height, resting on HP, and axis makes an angle of 60 degree with horizontal plane. So in this problem, first we have to think about top view, because angle with HP is given. So first we assume that the axis makes a right angle with HP, and in top view it would appear as a regular pentagon. So first we will draw pentagon in top view, then its front view, that would be rectangle as it's a prism, and then after the angle with HP is given, so we will tilt its front view at a given angle, that is 60 degree, and from that front view we will project the projections to the top view. We will draw its top view, and then by taking projections we will find the shape of top view. So let me draw this problem. So first of all, draw XY line that represents intersection of HP and VP, and then draw a pentagon below XY line such that one side, this side, is at right angle to this XY line. Insert the dimension, that is 30 mm in this case, and name the endpoints point A, B, C, D and E, and 1, 2, 3, 4 and 5, and then project, find out the axis. So for that, join this corner with the midpoint of opposite side, and join this corner with the midpoint of this opposite side, and both these line will cut at this point, and from this point join this point with all the corners, and name from this point draw a center line, or this is the axis of this solid. Now height of this solid is given, that is 75 mm. So at a height of 75 mm from this XY line, mark a point and draw projection line from this corner, that is 1, projection line from this. Name the endpoints A1 dash, 1 dash from 2 and 5, draw projection line here, B1 dash and 2 dash would be at the bottom, projection line from 3 and 4, so C1 dash, 3 dash would be here, D1 dash and 4 dash would be here. So here A, B, C, D and E would be here. So this A1, B1, C1, D1, E1 dash, all the points are on the top face, 1, 2, 3, 4, 5 are on the bottom face, and dash point indicates that it's a front view. So complete this. This shows the front view of this given solid. So here if you look from here, this 2 edge would be visible, hence this line would be fully visible. 5 edge will not be visible, so here dotted line would be there, which is overlapped by this full line. Now further it is given that the axis makes an angle of 30 degree with XY line. So here axis is making a right angle with XY line. Draw a line which makes an angle of 60 degree with XY line, because axis makes an angle with HP. redraw this rectangle over here such that this angle is 60 degree. So by redrawing this front view over here, name the points or transfer these points over here, A dash, B dash, C dash, D dash and E dash. Transfer these base points also, 1 dash, 2 dash, 3 dash, 4 dash and 5 dash, and then draw axis, this axis, transfer the axis to here. Here you can see this axis makes an angle of 60 degree with XY line, that is with HP, as it's a front view. Now to draw its top view, let me transfer the points from this view and this view, from this top view and this front view. So for that, if we're looking from here, this face ABCD would be visible. So let me first transfer points ABCD, vertical line from point A dash, horizontal line from point A1, both will cut at this point. So here is point 1 or point A, point B, horizontal line from point B1, vertical line from point B dash, both will meet at this point, that is point B. For point C, horizontal line from point C1, vertical line from point C dash, both will meet at this point, that is point C. Similarly, point D would be here, point E would be here, horizontal line from point E1, so here point E would be there. So we have identified 5 points A, B, C, D and E, and as it's a upper face or top face, it is towards us, so all these points should be joined with the full line because the upper face is visible to us. Now about this lower face, 1, 2, 3, 4 and 5, 1 vertical line from point 1, horizontal line from point 1, 1, here is the point, vertical line from 2 dash, horizontal line from point 2, here is the point, point 2, point 3, from here to here, here point number 3 would be there, point number 4 would be there, point number 5, horizontal line from 5, 1, vertical line from point 5, here is point number 5. So here 1, 2, 3, 4, 5 base is not visible to us, hence we have to join all these points with the straight line with dotted line. Now think about this, the axis, from this point draw vertical line,